For this part, we're going to discuss all about searching. So searching is a process used to find the location of a target among a list of objects. So when you deal with searching, you are not really getting the elements, rather we are getting the address of that particular element. So we have two types of basic searching methods for arrays. These are the sequential searching and the other one is the binary searching. So when we say sequential searching, it is normally used when a list is not sorted. And we are going to start it at the beginning of the list, meaning we are going to start it at position 0 when we are talking about arrays and searches until it finds the data or hits the end of the list or we hit the target. In a sorted list, the search terminates when the target is less than the current element, meaning in sequential searching, normally it is not sorted, but it can be also a sorted list. So again, when we are searching a value, it returns the address. In sequential searching algorithm, it needs to tell the calling algorithm first, we need to find the data it was looking for. And then what will happen next is we're going to find the index of the target data found. So here are the 4 parameters we need to search the value in dealing with sequential algorithm. First is the list we are searching or the array or the elements of array that we're going to look for. And then, of course, the index to the last element in the list or the size of the element. Remember that if we are talking about an array, if we have a size of 10, the first position is at position 0 and the last position is position 9. And of course, we need also to get the target or the key value. And finally, the address where we found the element's index location is to be stored. So meaning, once we get the index, we need to have another variable to assign that particular index. So let's say, for example, here is the example of an ordered list in sequential searching. If we want to search for 14, what we're going to do is to search it and look for it from the beginning of the array. So the first position of an array is the first element, which is 4. And then we're going to have an algorithm that compares the value of the first element to our target value. If the first element is not equals to the target value, then we increment the index position. Then again, same procedure, we're going to test the value. If the value of or the element of that particular position is equals to our target, okay, then we're going to send already the location on another variable. But again, if this is not the target that we are looking for, we need again to move on the next index until we find the target. So as mentioned a while ago, sequential searching would start at the first position or index 0. And we are looking for an element 14. So again, if we started it at position 0, we're going to compare the value or the element on the first position if this value is not equal or equal to 14. If it's not equal to 14, then we need to increment the value of the index. Repeat again the process of comparing the value or the element to our target value. As we get along with the indices and we find already the value of 14, we stop the execution of the loop. Then we assign the position to another variable and we're going to display that this particular value is at position 3 or position or index 3. Another example is if we are going to have the target of 72 and that particular value or the target value is not within the elements. So what will happen here is, again, since this is sequential searching, we're going to start it with position 0, compare it again to the target value. If it's not equal, then move to the next index. Then again, compare it again to the target value. If it's not yet done, the target value, we move it to the next index until it reaches the end of the element. So if the last element is not yet still equal to the target value, it means we stop the execution of the loop and we're going to return a value which is mostly or by default is a negative one. It means that we do not get the target value, or we can simply display, or we can simply say that target value is not found. So this is an example of a sequential search algorithm. So looker is the position. So we started it at first position, which is position 0. Then we can create a loop here. It's either a for loop or a while loop. And we are going to test whether the index is less than the last position. And another condition is the target is not equals to the list or the element within the list. So looker is equals to looker plus 1, meaning if that is not found, we need to increment the position or the index value. Then once, for example, we get the value of the target, or we get the index value of the target, then we can assign the value of the index to another variable. Here, we assign the value as allocation. Then again, we have the conditional statement. If the target is equal to the element inside the array, we are going to assign found equals true. That means we get and we found the elements in this particular position. Otherwise, found equals false, meaning we do not get the target. It means that we are going to display target not found in the list.